a small ruminant specialist with University of Missouri Extension. And before we start today, I want to just tell us a few things we need to note. Number one, please, the webinar is being recorded, and this will be posted on MU's Small Ruminant YouTube channel. So please take a note of that. Number two, if you have any question, please feel free to type your question in the chat box. The guest will make sure, as much as possible, that we answer the questions at the end of our presentation today. And like today's topic is strategies for managing dewormer resistance in sheep and goat. Is a broad topic, and we have a guest speaker that is Dr. Dalia O'Brien. She's a professor and small ruminant specialist, cooperative extension, Virginia State University. I actually got to meet Dr. Bryan when I was doing my postdoc, and she's a great speaker, and she's been working on this subject for a long time, and I believe today we're going to learn a lot of things. So I'm going to turn it over straight away to Dr. Bryan. Thank you, Dr. Bryan, for joining us today. I'll turn over to you.
Okay. Thank you so much, Dr. Brown, and thank you for inviting me to give this talk, and thanks to everyone who is joining us
This is Virginia
this
Tech.
afternoon. So welcome. So today we're going to cover strategies for managing dewormer resistance in sheep and goats. So we're not going to go into if I included the worms that affect sheep and goats, the talk would be extremely long. And so today we're only going over just the strategies for managing dewormer resistance. So let me see. You're still seeing my screen, right?
Yes,
Okay, the large screen.
yes,
Okay, good. So we know that all grazing animals are infected with worms. So every species that grazes, horse, cattle, sheep, goats, alpacas, llamas, they all are exposed to parasite larvae that are on that pasture. So they're gonna have parasite loads. The goal is to essentially keep these numbers low so that we're not seeing any clinical signs from any heavy loads or seeing any loss in production. So low numbers of worms will have no impact on grazing animals. However, high numbers result in clinical signs, and that's when we start seeing losses in production, start seeing growth rates decrease, start seeing them just not perform as well. We also know that sheep and goats are especially susceptible to internal parasites, right? And this is partly due to their grazing behavior. We know that sheep tend to graze extremely low, and they will actually find low areas in the pasture to graze. Um, on the other hand, we know that goats are natural browsers. So goats tend to 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 eat high off the ground if there are any shrubs, forages, anything that's higher. That's what their preference tends to be. However, if you look at many of our farm operations or goat operations, you will notice that we have limited the number of acreage that goats have, and a lot of times we have them on pasture. They're not they're not they don't have any browse accessible, and because of this we're forcing them to eat low, and by eating low they're picking up any larvae that's in that grass. We do not know that 80% of the parasite larvae are found 6 inches or below on a blade of grass. So once we force animals to eat low, then they're going to be exposed to those parasite larvae. We also know that sheep and goats have a poorer immune system. Sheep tend to have a better immune system than goats. Goats take a little bit longer to develop. Over time, once they're exposed to parasites, they should develop some resistance to it, right? So this is the goal. We expose them to low enough numbers so that they don't get clinical signs, but over time they develop a natural resistance to these worms. So in sheep, It's estimated that by the time they're around 6 months of age, and this varies from breed to breed, they tend to start developing some immunity, and goats tend to do this later on. And some goat breeds, it takes even longer. So those are some reasons why they're more susceptible to internal parasites. No, I'm a member. Before I go any further into this, because I'm not going to be talking about the individual worms of concern, I wanted to put a plug in for our website. So I'm a member of the American Consortium for Small Ruminant Parasite Control. I've listed our website there as well as the QR code to that website. If you have not visited our site, please do so. We have fact sheets on all the worms that infect small ruminants, not only the major ones, like the barber pole worm. We have fact sheets on tapeworms, nematodirus, all the others. Most of the problems that we have on farms come from the barber pole worm or Haemonchus contortus, and also from coccidia, right? But if you're having issues with any of the other worms, there are fact sheets out there on those that will give you some more information on those worms specifically. On the website, we also have online FAMACHA certification. So those are available. We'll go over FAMACHA and what it is today, but if you are not certified, you should become certified. And so we have online methods of doing that, and you can check out the website for that. If you've been taking parasite classes for a number of years and you think you've got a pretty good handle on how to control parasites on farms, then you could also become a certified FAMACHA instructor. And that includes submitting an application and taking a quiz. And a committee will review your application and see if you could be a FAMACHA instructor. You'd also be listed on that website. Additionally, the website has dewormer dosing charts, timely topics, best management practices, and a lot more videos and information. So, in case you haven't been to our website before, please visit. There's tons of information on that website for you to learn. Okay, so we're going to move now into the control strategies. So in the past, we relied heavily on chemical deworming to control worms. So we used to get our animals up every, and I might be telling my age by saying some of this, but I'm sure some of you remember when we tried to be more preventative, where we would get the animals up and deworm them every 4 to 6 weeks so we could prevent any issues from happening. Most of us at that time, if we did not have a scale, then we were estimating body weights and we were deworming based on that estimate and not on actual weights. So overuse and misuse of these dewormers has led to the development of dewormer resistance. So these parasites have developed resistance to a number of to the chemicals that are out there available for treatment. These are the dewormers that are available to us. There's a lot of dewormer names. You might see fenbendazole, or if you go into the farm store, you'll see Safeguard on the shelf. You'll see ivermectin, cydectin. You'll see a number of dewormers. However, dewormers only belong to one of three classes, and they're grouped into these classes based on their chemical structure and their mode of action. And typically dewormers, if worms on a farm or are resistant to a dewormer in one class, then it's typically resistant to other dewormers in the same class. So we might think we have a number of drugs in our toolkit to help treat dewormers, but in actually we only have three classes of dewormers. In other countries, there are more classes, but these are the ones that are FDA approved for use to treat worms in the US. So those are the three classes. We've got our benzimidazoles, which would include your Safeguard, your valbazen, macrocyclic lactones is the next group, and that includes like your Ivomec, your Dectomax, and then Cydectin, and then we have the nicotinic agonist, which would include your levamisole, um, Strongid, and so forth. So there are actually three classes. So what exactly is dewormer resistance? Um, Dewormer resistance is essentially when a drug loses its ability to effectively kill worms and the worms continue to survive in the presence of therapeutic levels of the drug. That is, when you treat the animal with that prescribed dose. So every dewormer comes with a prescribed dose. And when we treat that animal with that prescribed drug, that animal just simply isn't getting better or those clinical symptoms aren't going away. That indicates that those worms are resistant to the dewormer that we're using. We now know that resistance is inevitable. We cannot prevent it. I mentioned that there are other classes of drugs that are available in other countries, and within 5 years of being introduced, there's resistance to those drugs now. So it's inevitable. We can't prevent it. All we can do is slow it down. So the strategies that we're going to talk about today essentially will deal with basically how can we use dewormers less and how can we slow down the development of resistance in the worms on our farm. So we know that resistant worms, part of this problem is these worms are they're very prolific, right? They have a short life cycle depending on the time of year. And these worms, resistant worms, pass the resistant genes on to the next generation. So essentially we do not want to have our pastures populated with resistant worms because as the animals are consuming the grass, they're consuming these larvae, these resistant worms are developing and they're laying eggs that also are resistant. So we don't want to have our pastures populated with resistant worms, right? So the goal of what we're going to talk about is to reduce that. We also know that worms have developed resistance to all dewormers and all classes of dewormers. I already went over when to suspect resistance. We start suspecting that the worms in our farm are resistant to dewormers when clinical signs persist after treatment. So whether we're looking at FOMACHA scores or elements of the 5-point check, which we'll go over later, or just looking at growth rates, we're going to see that those clinical signs don't get better if our dewormers aren't working. And also, if you're monitoring fecal egg counts, you'll see that fecal egg counts remain high after treatment. The drugs just aren't effectively killing those dewormers. And this is assuming that we have used the correct dose of dewormer, right?
Hey, I just wanted to jump in, Dahlia. I think
Mm-hmm.
were you intending to display slides? At least I'm not seeing the slide display anymore now. I'm just seeing you on camera.
Okay.
So
So
maybe,
it stopped sharing?
yeah, maybe just try resharing.
Yeah, I
Okay.
just send you a message. We can see
Mm-hmm.
right here,
Oh,
you
you
know,
can
but
see them? Okay.
yeah, we can see, but
Okay.
possibly you want to try and log it again. You know,
Mm-hmm.
Dr. Brain can sh you can share
Let
it
me
again.
share again.
Okay,
Uh-huh.
Yes.
cool. Maybe it's just me.
I am so sorry for that. I
Yeah,
will
that's been
share
going
the
up again.
slides.
Yep.
I will share the slides.
Okay, is not on right now. Can you see?
Yep, now it's working. Thank you.
It's
Great.
working? Okay.
Yes, we welcome.
So yeah, all I have, yeah, I just unshared it and then shared it again. Um, so as I mentioned before, we start knowing that we have some kind of resistant problems if clinical signs persist and if E. coli counts remain high. The gold standard for determining dewormer resistance is doing what we call a fecal egg count reduction test. In the past, we did have a larval development assay that was available to us through the University of Georgia, where we would send a pool sample in. The cost was very expensive. I think it was like maybe $500, and that was a couple of years ago. And they would do an assay to determine resistance to all classes of the drugs. That test is no longer available to us. They're looking to set that up, I believe, at Louisiana State University right now, but we don't have that available to us right now. So the gold standard right now is doing fecal egg count reduction tests on farm. And so these can be done. The test is suitable for on-farm testing, and it can be done by a veterinarian, by trained producers, extension personnel. So if this is something you're interested in determining, then you can learn to do fecal egg counts yourself and determine the efficacy of dewormers. So essentially, what the fecal egg count reduction test is looking at how effective a drug is by comparing the fecal egg counts of animals before and then again after treatment. So trying to determine or looking to determine a percentage in reduction in that egg reduction. So a drug is considered to be effective if there's a fecal egg count reduction of greater than 95%. Anything less than that, we assume that resistance has started to develop. A drug that's 85% is still pretty effective on a farm, but once you start getting much lower than that, 65, 60%, then it really is not effective to use that dewormer as a sole method of treatment anymore. The fecal egg count reduction test, it does need about 10 to 15 animals to accurately test the efficacy of a dewormer, um, and they need to have at least 250 eggs per gram. There is a method available where you can do pooled fecal samples, so you don't have to do individual fecal egg counts. You could just get a fecal egg count on a pool sample, and that gives you a good estimate as well. But that's the gold standard for determining dewormer resistance. And if you are interested in doing that, you could work with your extension personnel or veterinarian in getting that done, or you could try to learn to do fecal egg counts yourself. Is my slide still showing? I had to move my mouse
Yes,
around a
it
bit.
is showing,
Okay.
Dr. Brand. Yes.
Okay. Still?
Yes.
Yeah. Okay, good. So what do we know about the status of dewormer resistance on farms in the US? Back in 2009, my graduate student did a study where we assessed 33 farms in the mid-Atlantic region of the US to determine efficacy. And what we found was that on all 33 farms that we tested, the benzimidazole class, the one that included Safeguard, Valbazen, the farms we tested, 100% of the farms we tested had resistance to benzimidazoles. Um, Ivermectin was, I believe it was about 82%, moxidectin about 47%, but you can see that it's coming down. And part of that has to do with how long ago those drugs have been available to us. The more that we've used those drugs over the years, the longer we've used those drugs, the more resistance there is. And levamisole, um, a lot of because of toxicity issues in animals, there were a lot of farmers who hesitated to use levamisole as much, and you can see that that was the most effective. And remember, this data is from 2008 to 2009. Back in 2016 to 2017, two colleagues, a colleague in Maryland and a colleague in Georgia, and I came together to simply to test sheep farms. So we decided to do 10 sheep farms in each state and look at the status of dewormer resistance. And again, we found that benzimidazoles, 100% of the farms had resistance to that. Um, 97, I think that's 87%. Um, then about 40 something percent, and levamisole was still the most effective drug on most of the farms that we tested. When you looked at all drugs, there were about 15% or so of all farms that had worms that were resistant to multiple drugs. So multiple drugs across all three classes, and then there were about 25% or so in the later studies on the sheep farms that had worms that were resistant to all classes of dewormers. So we know that it's an issue, and now the last data on that was collected back in 2017. So we're assuming that resistance hasn't, the status of resistance hasn't gotten better, even though we've been doing our best to do integrated parasite management trainings and to get producers from ARCHA certified. We're just assuming that this is it still hasn't gotten, it hasn't gotten any better. So it is a problem in the US, it's a problem worldwide, and the solution solution in other countries is to develop more drugs or more classes of drugs. and even to have combination drugs, drugs with multiple classes to deworm these animals with. And we'll talk about that some more, how effective combination treatments could be. So, with a number of farms in the US experiencing not only drug resistance but multi-drug resistance on their farms, then um, as a group, the consortium came together and conducted a number of research projects and worked on a number of alternative strategies for effective parasite control on farms in the US again and also worldwide. The consortium consists of members from South Africa, Australia, and other countries as well. And the overall goal of these strategies, again, to reduce drug use, so rely on chemical drugs less, um, and this will help us to basically slow down the rate of drug resistance on our farms by using alternative strategies. So we essentially came up with sustainable integrated parasite management toolbox. And the toolbox contained a number of tools that can be used to help in doing those two things I mentioned before, reduce drug use and slow down the rate of drug resistance on farms. So when we talk about sustainable integrated parasite management, we're talking about a chemical approach and then a non-chemical approach. And the chemical approach is the use of drugs still. So not completely take out using drugs, but using drugs more intentionally. All right. So targeted selective treatment, and I'll go over exactly what that is. And that's basically utilizing like FAMACHA and 5-point check to discern animals with clinical symptoms and who needs deworming. And so the other side of that is non-chemical approaches to parasite control. And I'll try to go over, touch on all of these during our talk today. So targeted selective treatment is simply just deworming only those animals that require treatment. All right, so it uses two tools, and these tools were developed in South Africa. So it uses the FAMACHA eye check and also the 5-point check, which includes the FAMACHA, and we'll go over those specifically shortly. But it uses those two tools to identify animals that are susceptible or not to worm infections. All right, and so that helps us to manage drug resistance and decrease how many animals we're deworming on our farm. And what this technique does is it slows down resistance by increasing refugia, and that's the number of worms that are left in refuge from the drug. If we consider that the animals on our farm, all right, all the animals on our farm that are out grazing have both susceptible and resistant worms in their digestive system. If we dewormed all animals like what we were doing years ago, I guess now it's decades ago, if we deworm all the animals in our herd or flock and we deworm them based on their weight, accurate dosage, and we say that our drugs were highly effective, right? Greater than 95% efficacy. Um, you know, then when we dewormed our animals, because remember, even though it's 95% effective, there's still 5% surviving, right? So if we deworm those animals, then all the susceptible worms would perish, and what's left? Only the resistant worms. So you can see that this problem is made worse if we have drugs that we're deworming with and they're not as effective. Okay, so they're not there is resistance to that drug. So all the susceptible worms are being knocked out and only the resistant ones are surviving. If we deworm based on symptoms only, if we're deworming based on their FAMACHA scores and any other indicator of parasitism, if we're just picking out, the few animals to deworm, just the ones with clinical symptoms, then what we're doing is we're leaving some of those worms in refuge from the drug. And so instead of having our pastures being populated with just resistant worms, we have our pastures being populated with susceptible and resistant worms, with the susceptible worms diluting um, some of the resistant worms. I hope that makes sense. So that's a more effective way to reduce our use of dewormers and slow down resistance. So the two tools that were developed were the FAMACHA eye chart. So this is a system that was developed in South Africa in response to the emergence of dewormer resistance. And the next tool is the 5-point check, and we'll talk about that in the next slide. So this has been validated for sheep, goats, and camelids. And it's a system that's used to assess the level of barber pole worm infection in sheep and goats. So it's specifically used for barber pole worm because it's rating the eyelid of an animal on a scale of 1 to 5, with 1 being bright red, healthy, 5 being basically at death's door, needed deworming, and severely anemic. And remember, anemia is one of the number one symptoms of barber pole worm infection. So that's all this strategy is testing for, is barber pole worm infection. All right, so we can go through, check our animals using this eye chart, determine who needs deworming or not based on that I score. We typically recommend deworming a 4 and a 5, a 3 depending on their production status. For instance, if they're young animals are highly susceptible, we would deworm a 3. If it was a dam with her kids or lambs, then we would deworm that animal. If we weren't able to check for matcha scores again in say a week or two, we maybe consider deworming a 3, or if it had any other signs of parasitism, such as a diarrhea or rough hair coat wasn't growing, then we would consider deworming a 3. But it gave us a tool that we could use to individually assess animals and deworm based on that clinical symptom. Now, to get a FAMACHA card, you must attend a training, or consult your local veterinarians, because most veterinarians have FAMACHA cards and they'll do a training if you ask them. They might charge you for the card, but there's an online system again I mentioned at the consortium website at wormx.info, where you can do an online FAMACHA course and get your card mailed to you. If you are not, I'm hoping that most of you on here are FAMACHA certified. I guess I should do a quick poll and see. I hope most of you are. Um, Otherwise, let Dr. Brown know so he can organize a workshop, or you
Yeah,
could go online, as I said, to do that.
we actually do fields day every year, and the last 2 years
Good,
we've been doing farmacia training.
good, good. Because everyone, I am always amazed sometimes when I go to meetings and I'm like, and I ask folks, and there's still folks that aren't FAMACHA, certified. We've been doing this now for a number of years, and most people should be certified. So the next tool that we have is the 5-point check. So this check addresses limitations of the FAMACHA because it doesn't only consider clinical signs that are due to the barber pole worm, but also clinical signs that might arise due to like a co-infection with other worms. So it also checks the bottle jaw is a symptom of the barber pole worm as well, but it looks at the body condition score of the animal. It takes into account diarrhea by looking at the DAG score. It takes into the account any nasal discharge, some nose spots. So and it also does the FAMACHA. So those 5 checks. In goats, we replace coat condition for nose, for checking that the nose for any nasal discharge. But you should be using these tools. We recommend the 5-point check because it includes the FAMACHA and the bottle jaw as well. So you should be looking at the entire animal, not just at the eye or not just at the jawline. Look at the entire animal. And there's some experts who advocate the happy factor, they consider it, or looking at other methods, such as if you have young animals that are growing and you're weighing you're taking their body weights, check to make sure that they're gaining weight. If they should be gaining weight, that they're gaining weight. So their average daily gain. So they're either increasing or maintaining their weight. And if not, then these animals might benefit from a dose of dewormer as well. So those are the two tests. And I often get asked, what about fecal egg counts? Could I look at the results of my fecal egg counts to determine the need to deworming? Um, in most cases, we say no. You only look at fecal leg counts in some cases. The best uses for fecal leg counts is essentially to monitor the rate of pasture contamination. So if you have animals out on the pasture and you're trying to decide how infested or wormy that pasture is, you could randomly take some fecal samples, take it back, give it to your vet, or if you have a microscope and you do fecal leg counts and check the fecal leg count to determine if most of the fecal counts are high, you see a lot of eggs, then that would indicate that that pasture is infested or has worm larvae on it. It's effective for determining drug resistance, as I discussed before, and it's highly effective in selecting and culling animals. And I'll talk some more about this when we get into resistance or resilience. Um, there are charts and tables out there that will say if your animal is above a certain fecal egg count, then you should deworm them. So it might say if it's above 2,000 eggs per gram, deworm them. But if an animal has, say, about 2,000 eggs per gram, say it's in a group of other, open females who are not susceptible, and it has a fecal egg count less than 4,000, sometimes I might not deworm that animal, right? If that animal has a fecal egg count above, say, 4,000, and it's in a pasture or pen system or whatever with more susceptible animals, so maybe animals that are late pregnant or lactating, maybe animals that are with younger animals, then I would typically deworm that animal because not every animal with a high fecal egg count is going to have clinical signs. Remember, um, an animal can be highly resilient, have high fecal egg counts, and that fecal egg count is not affecting it. So FOMACHA scores are good, everything's good, and it's just not being affected by that parasite load. However, by dropping those parasite eggs on pasture, it is leaving larvae on there that other animals, more susceptible animals, might be exposed to. So those are some things that we might take into to consideration. We never really say to use it by itself as a sole means of deciding whether or not to deworm an animal. It should be used in conjunction with FOMACHA, 5-point check, and again looking at that situation, that pasture situation. Who's it housed? What are the other animals that it's housed with to determine the need for deworming. So we talk about using these methods to determine who needs deworming or not. So if we're going to have to be using chemicals, these drugs on the farm, then we should make sure that the chemicals that we are using them for their maximal efficacy. All right. So when you do have to deworm animals, so if you've identified a few that you have to deworm, you still should be making sure that you're giving the correct dose. Remember, part of our strategy is to slow down the development of resistance. So we want to make sure that when we do have to deworm, we're using effective dewormers, and we'll know this by doing fecal egg count reduction tests. And we're also given the correct dose. So make sure we are weighing these animals. The least you should be doing is using a weigh tape or measuring tape to estimate their body weight. So you have an idea and maybe estimate the heaviest and go by that weight. The only dewormer class that said not to do that with is levamisole, because if you overdose, then that could be toxic to the animal. But make sure that we're weighing these animals so we're giving the correct dose. Again, the wormx.info website has dosing charts for all the dewormers that are out there. So whether you have, and it's by species. So there's a dosing chart for sheep, goats, and there's one for camelids as well. So I have a laminated sheet that I keep in the barn, in the sheep barn, so that I have that when I need to deworm um my animals. Make sure you're also drenching these animals correctly. I can't tell you how many times I've been to farms and I've seen it's gotten a whole lot better, but I still see folks using just like a regular syringe to just like squirt that dewormer in the animal's mouth. You should be using a dosing syringe with a long metal nozzle because essentially you do not want to bypass the rumen. You want the drug to go exactly that path where the worms the parasites are. So if you allow that animal, if you just put it at the tip of the mouth and make it suckle, then that esophageal groove, that suckling reflex is going to come into play. And what it does, it bypasses, if it's sucking, it bypasses the rumen and goes straight to the abomasum. We don't want that to happen. So by using a long metal nozzle and putting this over the tongue towards the back of the mouth, we're ensuring that we don't bypass anything and it's following that same path as the worms. So make sure we're drenching correctly. Um, then
Yeah,
next we,
Dr. Brand is 10 minutes more to finish.
okay,
He asked me to
okay,
remind you. Yeah,
thank you. So
you're
the
welcome.
next thing that we're doing is that depending on the efficacy of our dewormers or not, we want to make sure that um we're using the most effective combinations. Most of us don't have dewormers that are highly effective anymore. And so what we're recommending now is that we combine dewormers. So this is the most effective way of killing or reducing the fecal like the getting the highest efficacy when we combine these drugs as opposed to individually. And I'll show you a chart after. So, as the effectiveness of a dewormer decreases, it provides less and less benefit of using it. And we now know that rotating between dewormers that does not prevent resistance from worsening. Um, and we no longer recommend it. But you can use dewormers at the same time, not mix together or anything, pull up that correct dose for that animal, pull up each drug and deworm them back to back. And the reason why I'm saying that, if we use a drug that's say 80% effective, one drug, even though it's 80 or 85% effective and we deworm that animal with 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 that dewormer, there is still 15 to 20% of those that are resistant. So we're still populating our pastures with those resistant worms, 15%. If we use two drugs or even three drugs that are 80% effective, we've brought up that combination to 96 if it's two drugs, 99% if it's three drugs. What we found is that there's an additive effect. One drug kills 80% of of the worms. The next drug kills 80% of the remaining 20%. The next drug kills 80%. So combined together, it totals 99%. So if we use the one drug that's 80% effective, we're allowing 20%, those resistant worms to pass on that pasture. By combining all three, it's 0.8%. All right, so we're populating our pastures with less resistant worms. I hope that makes sense. So that's the recommendation now, is to use a drug from each class. And so this gives you an example if we're using valbazen, cydectin, and prohibit, and it includes the dosage and the withdrawal periods in there. And what we do is we give them a drug from the most effective drug from each class, and then we deworm them with all three dewormers, and we just follow the withdrawal period of the longest, the one that's longest. So in this case, the one that's longest, if we look in the goat column, Cydectin's 17 days for meat, that's the one that we would follow. So using a drug from each class and deworming them their prescribed dosage, just drench them back to back. All right? And so that's what we're recommending now. Now looking at non-chemical treatments. So non-chemical would include nutritional management. We know that good nutrition supports a good immune system. And good nutrition makes animals more tolerant of disease. And internal parasitism isn't disease, and it possibly makes them more resilient or resistant to these worms. All right, we know that protein aids in rebuilding tissue, minerals such as copper and zinc support a good immune system. So making sure we're providing a good nutrition goes a long way in helping to control parasites. Research has shown that if we supplement use during the last 6 weeks of their pregnancy, remember that during that stage, their immunity drops, right? So during that stage of gestation, late gestation, around late gestation, early lactation, their immune system drops and they become more susceptible to parasites. Research has shown that if we feed them a diet higher in protein during that period, then that will help them to fight. Um, to combat parasites. The same thing with lambs. If we supplement with our young animals, if we supplement lambs or kids or young animals adequately, then that's been shown to reduce the effects of internal parasites on those animals. And of course, we know zero grazing. A lot of countries, I visited Jamaica in November of last year, and they've gone almost completely now to where they're raising their goats on slatted floors and they're cutting the forage and bringing it to the grass to help reduce the incident of these worms on these animals. Um, Pasture management is another tool that we should be using. We know, as I mentioned before, that very few larvae get above 4 inches. Um, on that blade of grass. So one of the first things that we should be doing is to try to use strategies that prevent our animals from grazing below that. If we try to do that, then it reduces the chances of them coming in contact with that worm larvae to ingest it. So monitoring forage height and making sure they don't go graze too low. We also know that larvae migrate approximately 12 inches from a manure pile. And so using the biology of these worms and using just the or pasture management skills, we can ensure that they're not exposed to as many larvae on pastures. Rotational grazing is an important management technique. We know that in the height of the parasite season, it takes about 3 to 7 days from the time that animal has passed those eggs in the manure till it hatches and become an infective larvae that they can then ingest again. We know that takes about 3 to 7 days. So you might see some rotational grazing strategies out there that say they're rotating them every 3 days. So essentially, they're trying to move them off that pasture before they start picking back up those same larvae that they passed onto those pastures. Um, Managing grazing heights, I mentioned that before, not allowing them to graze too low, maintaining low stocking rates. Essentially, one of the biggest reasons why we have such a huge problem now is because we're forcing animals to basically eat where they defecate. We're putting them on small acreage of lands. The eggs are right there in that manure. And so if there's manure, if we have high stocking rates, there's manure all over that pasture and they're going to be exposed to the larvae. Multi-species grazing has been shown to be effective. Um, Parasites are species specific, and so one species essentially acts as a vacuum and ingests some of those larvae. Um, the larvae that affects the other species and helps to clean up that pasture. So we always tell folks to lead with a susceptible group. So you could follow behind your sheep and goats with cattle, horses, and allow them to clean up that pasture some before you bring your sheep and goats back to that. Even within the same species, you could do that. You could have your adults following behind your young animals. So you could, when you put your young animals out to graze, have the older animals who should be more resistant come behind them to help clean up that pasture before we put the young animals back on it. Access to browse and bioactive forages. I'll talk some more about Sericea lespedeza before we finish, but again, this has to do with keeping them from direct contact with the larvae that's on that grass. The use of annuals, harvesting hay, increasing forage quality, as we talked about, nutrition is important. All those will help to alleviate some of the parasite issues that you have. In non-chemical tool, we talked about using tools like FAMACHA and the 5-point check. I know there are some farms that have large numbers of animals on their farm, and just want to point out there's some animals on the farm that will be more susceptible to others. Your young animals, kids and lambs, peri-parturient females, old animals, and you're less susceptible, those that have should be exposed to it enough that they've developed some immunity or resistance to it, the bucks, open does, any pets. So during the summer, even if you can't get around to checking FAMACHA scores or 5-point check, if you can't get around to doing that with all the animals on your farm, you should be checking at least the most susceptible animals to determine the need to deworm those. Then looking at genetic selection, again, we know that the ability to regulate worms is under genetic control. We know that there's some worms that are resistant to worms naturally, and then some animals that are more resilient to worms. So resistance is the ability of the animal to limit infection. So for whatever reason, that animal can consume those parasite larvae. They don't establish inside the animal. Um, and so that animal consistently will demonstrate low fecal egg counts. They just don't establish. So those animals, they will never have clinical signs. They'll never have high fecal egg counts. That's an animal that's truly resistant. And then we have resilient animals, and these animals have the ability to withstand infection. So they can have high fecal egg counts. So these tend to be wormy. So when you check their fecal egg counts, it's high. So you'll check that they're high. Um, However, they have good FAMACHA scores, no clinical signs, and those animals are the ones that are resilient to worms. There's some, my colleagues and I debate all the time about resistance versus resilience. Which should we pick? I'm all for resistant animals, not resilient animals. And when you just use tools like FAMACHA or 5-point check, remember you're looking at clinical signs. Both resistant and resilient animals will have no clinical symptoms. They won't show clinical symptoms. The only way to differentiate a true resistant animal from a resilient animal is essentially to do fecal egg counts, in addition to FAMACHA checks and all that. That's the only way to do that. We also know that there's some breeds that are more resistant than others. So when you're thinking about goat breeds, Spanish, myotonic, there's data coming out now showing myotonic um, are more resistant compared to some of the other breeds out there. So there's some breeds that are more resistant than others. When you're talking about sheep, you're talking about here sheep breeds tend to be more resistant than wool sheep breeds. And even in wool sheep breeds, there's some breeds too, like the Texel breed that is more resistant. And even within breeds that are susceptible to worms too, we should evaluate animals based on their individual merit. There's some animals within, every breed that are more resistant to others. Um, we should always keep in mind this is a reason why genetic selection is important. We should keep in mind that resistant dams and sires will most likely produce resistant offspring. So when we're doing our selection, selecting our replacement females, we should be checking fecal egg counts so that we're selecting the most resistant females, right? And when we're purchasing our males, we should be trying to get males that have some data, parasite data or something on them that are truly resistant because a lot of times we do single sire matings and that sire or male will contribute 50% of the flock genetics. And so we should make sure that we're selecting a male that's parasite resistant because they do pass those traits on to their offspring. Additionally, what I want to point out in terms of, genetic selection too is the 70-30 rule. You'll see it sometimes referred to as the 80-20 rule, where 30% of the flock or herd which will shed 70% of the parasite eggs in on your farm. So if you can identify those animals and you can cull based on those high fecal egg counts, then you're doing your part in helping to select more resistant animals to keep in your breeding herd. Or your flock. So we should always keep this in mind and select based on that. In terms of herbal dewormers, I know I'm coming pretty close. I'll finish up in a few minutes. I want to mention in terms of herbal dewormers, there's a lot of anecdotal evidence out there that herbal dewormers work. I have never seen any scientific data that supports this. There's always inconsistent data. But again, if you think about how different projects are being done, like when you look at pumpkin seeds, I will say I've seen pumpkin seed studies done where, where people have made a drench out of the pumpkin seeds or they've fed the pumpkin seeds and they're feeding different varieties of pumpkins. And a lot of the studies, there's no consistent, you know, body of research on, like, say, one, just one type of pumpkin or one method of a drench or pumpkin seeds or whatever. There's inconsistent data out there. We know active ingredients vary, and I always suggest that if you're gonna use herbal dewormers, then it should be used in conjunction with other methods of integrated parasite control, and they should not be used by themselves. Copper oxide wire particles. This is opposite to the herbal dewormers. There's a number of research out there. A large number of research projects have been conducted that show that copper oxide wire particles are effective in controlling the barber pole worm specifically in sheep and in goats. Um, there used to be higher doses. We know copper is important for immune function, and we know it's available commercially to alleviate copper deficiency in ruminant livestock. And before they had higher doses, now they have smaller ones that are out there that we could use to act as a dewormer. It's important to note that if there's a mixed infection or there another worm is more dominant in that population, then the effects might not be as well because again it targets the barber pole worm. And we've also found that when you can use copper oxide wire particles in conjunction with chemical dewormers to have a greater efficacy in fecal egg count reduction. So if this is the route that you'd like to go to use copper oxide wire particles, you could use it with a chemical dewormer to increase the efficacy. There's some data out there that shows then that's effective. Sericea lespedeza, a number of research done on that too. The presence of the condensed tannins has been shown to reduce worm infection, and this is effective against the barber pole worm and coccidia eggs. And this is one product that's been found to reduce fecal egg counts when grazed, when fed as a hay, or when fed as a pellet. So in all forms, it has been shown to be effective as uh, as a dewormer. Of course, nothing's going to be as effective as a chemical dewormer, but it does reduce fecal egg counts as well. Um, the last thing I want to touch on is the fungus. The nematode trapping fungi, Dodintonia flagrans, which is a naturally occurring fungus that when we feed it to animals, it survives their digestive tract, is passed in the manure. When the egg hatches, it traps that larvae and prevents it from developing. So it's a natural product that's out there. It has been available to producers in the US since about 2019 or 2020. And it is highly effective in reducing larval counts on the pasture. It doesn't treat the animal. It does nothing to the worm load in the animal. It treats what's on the pasture. So we know that about 10% of the worm population is inside the animal. If we consider that the animal forage situation, 10% of the worm population is inside the animal and 90% is on the pasture. All right, so if we give a drug that's 95% effective and we deworm the animal, that only deals with that 10% inside the animal. A product such as Dodintonia flagrans or biowerma, as it's commercially available, if we're treating the pasture, and research has shown it's been fed to horses, cattle, sheep, and goats. On average, it's about 70% effective in reducing pasture worm loads. So it is highly effective in reducing the larvae that's put out on the pasture. Final thoughts, drug resistance is not a death sentence. There are a number of tools that you can adopt. We talked about a number of them in using your drugs more strategically, in using non-chemical approaches to parasite control. All those, if we do a more holistic approach, then we become a more sustainable industry, I believe, especially if we start using genetic selection, if we focus a lot on that. Um, and we're choosing or selecting more parasite resistant animals to make our flock stronger or herd stronger, then we will become a more sustainable and hopefully a more profitable industry. So by efficiently managing your available resources and selecting your breeding stock more strategically, then we can go a long way in dealing with or managing dewormer resistance on farms. So I'm done. So sorry I went a
Thank
little
you.
bit over.
Yeah, that was very informative. Thank you so much, Dr. Brand. Excuse
No
me. And
problem.
most of the questions, I think you covered them.
Mm-hmm.
Excuse me. People were asking about the Cerisa Lespedeza. But
Mm-hmm.
if you want to please, if you have any question, can you please throw out there? You're free to unmute yourself. But people are asking about the AU
Let me see.
grazer. You know,
Mm-hmm.
and of course it contains
Mm-hmm.
tannin and the effect of tannin, in
Mm-hmm.
reducing the worm load. You want to please talk about that, Dr. O'Brien?
Yeah, so sorry I went over those in such a rush at the end. I'm trying to keep on time. It's a long topic and we could talk forever about these things. Yes, so most of the studies out there have been done on the AU grazer. So that's out of Auburn University. And so you can there's certain seed stores that sell it. I imagine in other parts of the country, just depends on where you are. In Virginia, there's probably one or two. And it's the same thing with the Sericea lespedeza, these are pellets. But if you go to the website, there are instructions on how to try to seed your pasture and grow this. It won't grow everywhere. We tried in years to grow it in Maryland. We could not. In Virginia, a few of our producers have had success and have been able to sell that as a hay to use in parasite control. We have had very good luck using the pellets in feeding our goats at weaning to help deal with or coccidia issues during that stressful time. So again, it's really effective in reducing that fecal egg counts. Not as effective as chemical drugs, but in keeping it, controlling it enough so we don't see clinical symptoms and effects on production on it.
Great, thank you.
Hmm.
Tammy ask you a question. I don't know if you can say this. Is there any research on resistant drugs becoming more effective on the farm once good management practices have been
Okay.
ineffectively utilized for a few years?
Okay, so if you use, there is no, the only research that I'm aware of is using bioworma to replace resistant worms. Remember, if your farm has resistant worms, um, you would think, in theory, if you use these practices for a number of years, then you're avoiding to use dewormer, then they're more susceptible worms on your pasture, so resistance should change. I don't know of any project or research that has monitored this and recorded this actually happening. I do know there was a study done by Delaware State University using bioworma to replace resistant worms on that farm by putting a population of susceptible worms in parasite naive animals and allowing them to populate the pasture. And the resistance on that farm did change. And I think for levamisole, there was indication that it could be reversed if you hadn't used it in a number of years. But if you went straight back to using it before, then it would build over and it'll build again in no time. So yes, so you're prolonging the efficacy. Yes. How much of an increase in efficacy you're getting by doing that, I'm not sure. I'd have to look that up.
Okay, great.
Hmm.
A question came in right now, of
Hmm.
course, via my email. How
Hmm.
often should I rotate dewormers to minimize resistance development?
Repeat that.
How often shall I rotate dewormers to
Hmm.
minimize resistance development?
So we no longer recommend rotating dewormers. All you're doing is by rotating dewormer, you're building resistance to that to that drug still faster. What we recommend is using combination treatments to treat your animals. They're just more effective. So taking the most effective drug from each class and deworming your animals with that. If you would don't want to do that, then you could also use copper oxide wire particle combined with a chemical dewormer to deworm your animals, but we're no longer recommending rotating dewormers.
All right, one final question, Dr. Brand.
Mm-hmm,
I think you talked about that when you're talking about the
mm-hmm,
5 point check. What
mm-hmm,
role does nutrition play in reducing susceptibility to internal parasite, which you
mm-hmm.
talked about during 5 point check and other stuff?
Yeah, so nutrition is highly important as a measure. Protein helps to rebuild tissue. Copper and zinc important for an immune response. I can't tell you, I've been to farms where they're grazing so low, there's nothing there. These animals are skinny, and a producer will ask me why are my animals suffering from parasites. If you feed your animals well, they will be able to resist and deal with that parasite infection. Um, they will be able to deal with that a lot better. We just did a project last spring where we supplemented our animals or not, just left them on just on pasture too. It was spring, so we had pastures to put them out on. So we supplemented half we supplemented some with 16% crude protein, no supplementation for the other group, just on pasture. We saw drastic differences in the weaning weight of those kids, the performance of those ewes, and it even went further to how they grew post-weaning. Supplementation at critical times is very important to make sure that they deal with parasite infections better. It does help.
Thank you, Dr. Brown. We have to let you go
You
because she has a class right now.
I do have
They,
to teach.
they are great comment. People, appreciate your talk. Thank you for coming
Mhm.
to give us a talk today. We appreciate you. Please know that we're going to send the slide of this presentation to everyone and also the recording will be made available. And don't forget, we have a special class next week. Next month, webinar
Mhm.
session. Look out for that. A lot of other interesting programs. And we look forward to having you again next week, next month. Thank you, Dr. Brand,
Doc,
for coming. And
Dr. Brent,
thank you
I
all for
saw,
joining.
yeah, just one question I saw before the copper oxide wire
Oh,
particle.
okay.
If
I
you
didn't
could
see
use
that.
that in sheep, yes, you could. We've had no toxicity issue in our sheeps when using copper oxide wire particles. Um, if you use the lowest dose possible, you can use it and it is effective. But just go with the lowest dose possible. And that should be fine.
All right. Thank you.
Hmm.
Okay.
No
Thank you
problem.
all for
Thank you.
joining and have a
Thank you,
good rest of
David.
your day.
Hmm.
Bye.
Okay, thank you, David. I'm going to drive across the
All
class
right.
now on campus. Take care and good luck, and let me know if there's anything I could ever do
Okay.
to
Thank
help.
you, Dr. Brown. I appreciate
All right.
that.
Take care.
Bye.
Bye.